In this video, we're going to go over how to use tables in the Lua programming language and how that works in the game command. So I'm going to do the best I can at this. The tables get really complicated, and while trying to work with this while doing a video at the same time, I'm not the greatest at it. It's probably going to be full of mistakes that we'll correct as we go. So I'm going to start out with just showing some very simple examples of what a table is, and then I'm going to show some complicated things, but generally in the game you're going to be using the simple version of it. But tables can be very complicated, and some of the things that you see being used in command might not work all the time with all different kinds of tables. So a table is just another data type. We've already been over some of the other ones. A string, which is usually words or text. Numbers, which are numbers. Boolean values, which are true or false. We've done some functions, which I believe are a data type, and now we're going to be doing tables. So a table is, we're going to call our table T, and to create a blank table, you just do the open and close curly quotes. Something that's enclosed in curly quotes, generally speaking, is going to be a table, and then we're going to do print T. And so when it printed out the open and close curly quotes, curly brackets, I mean, not quotes. It didn't print out nil, even though there's nothing in the table. This is not equal to nil. If I get rid of the open and close curly brackets, you can see now it's equal to nil. And now it's being back to, it's basically an empty table. So if you're checking to see if a table that doesn't have anything in it is nil, it's not going to work because technically it's still just an empty table. Now, in other languages, if you've used JavaScript, a table can be similar to an array or an object. It can actually sort of be both. So it gets a little bit confusing when people are talking about arrays or objects in tables. But at its simplest, we can just say we're going to put a few things into a table, and this is in one way to create a table is to just explicitly define it. And this is going to be a table that's made up of the strings A, B, and C. And now when I print it, so you would think that all the table really is what you're seeing right here. Since when you printed it with nothing in it, it printed the left and right curly brackets. You would think now it's just going to be A in quotes, B in quotes, C in quotes with the commas in between. When you run it, you'll see that what it really is it added an index to each one of these. And if we add in a fourth one, and keep in mind every time I run it, it's wiping out the prior table and we're starting from scratch. Now we're up to index number 4. So another way you could have created the table, and let's maybe we'll make another one down here. So now I'm going to make another table down here, and we'll call this local table. And we can define those indices if we want to. I'll just do the first two. And now when we run that, and we get an error, of course, near the beginning one, because I don't have an equal sign in here, of course, local table equals. And now you can see that, what's it doing? I didn't print out the table, so let's print table. And you can see that it's still printed out those same indexes. So that's when you're creating the table, if it's just going to be an array-like table, which is what this is, an array is sort of an indexed list of items. You could declare the index item here as you're doing this. It's just shorter to do it this way. I'm going to come back to why this can be a problem later on, but we're going to skip it for now. So once you have an array like this, let's make sure it still works. One thing you can do is get the count of how many things you have in here. And if you can do that by putting the pound sign in front of the table name. The table name is T, and now it's just going to print how many items are in there. If I add another one, the count's going to change, and now it's up to 5. So if you want to get a list of the values that are in the table, there's a special helper function in Lua for doing that. We're going to do for k comma v in pairs, and the name of the table in parentheses, and I'm just going to print out the v, which should be the value that's in the array or in the table. K is the index. And let's see what we get. Let's see, first thing we got is 5 from this. A, B, 1, 2, 3, 4, 5. Yep. This first part here, maybe we should we should make this more clear. And then we need the dot dot syntax. Count equals 5, and then this is the value of each one of the 5s. If I switch this out with k, then it'll just be 1 through 5. And now I'm not 100% sure if you can skip one of these. So let's try and delete that and see what happens. It still works. What if we change it to v? Yeah, it's just printing out the index part. That's why you need the second one. And now I'll just say it's v comma I and print I. Yep, now we're back to getting the value of it. Okay, so in the background you can see here I'm on this Lua FAQ page in the background because I did have a problem before we did this where it didn't work. And you'll see where it says I pairs, there are two functions to help you loop through the items in a table. And in the context of what we're doing here, where it's a simple array, it doesn't matter which one of I pairs or pairs you use, but it does matter, as well as this count up here where we're using the pound sign to get the count of a table. So as we've done it here, this is a pretty simple example of what a table could be, and generally in the game, this is how you'll see it used, that the table will be a list of units or maybe some reference points or something like that, and generally it's a pretty simple table. But a table can also, let's see if I believe we went over how you can declare the index. Did we do that? Yeah, I believe we did up here. You can also use the table to hold like a dictionary where it's a key value pair. And right now, as it is the way we're doing it, the key has been the index number 1, 2, 3, 4, or 5, and then the value has been A, B, C, D, and E. It doesn't have to be like that. You could do a table where, and remember the index, the first part of the pair is in brackets. We could call this, what is that? Game, and then the value could be it's equal to, and now when we do this you're going to see, hopefully that it'll work. Let's run it first and see if it works. Yep. And so down here it just we have the loop going through printing out what the value of the value of the value is in the key value pair. So it just printed out CMANO at the bottom. But notice up here it said count equals 0. This pound sign only works on an array like table, so they have to be in consecutive order. If we go back to one of these examples here where, yeah, just this example here where we have A, B, C, D, and E, I can also set the next the next item in the table, I can set its index number, and we'll call it 22 equal to F. And this is going to be this should be a valid table. Yep, A, B, C, D, E, and F. But the index number is not consecutive. So this is index 1, 2, 3, 4, 5. There should be 6, but on the count it's saying it's 5. This pound sign here, to get the count of the items in a table, only works on a simple array where they all are in consecutive number. As soon as there is a gap, the count stops. Likewise, if the table is made up of key value pairs that are not an index number, where you have the game equals CMANO, or they're more like a dictionary, the count doesn't work at all. This also gets back to where you have I pairs and pairs. I pairs, I believe, is only going to do the array part of this, so it's not going to print F. Check that out. I actually know what I'm talking about sometimes. Whereas the pairs prints everything in there. I haven't quite gotten to why you would... I guess I sort of could see why you would want to use one or the other. That you might have a mixed table that has an array of stuff you want to use, and then you stuff some other stuff in it at the end that you don't want, and then you'd want to use the I pairs just to get the array, whereas pairs will do the whole thing. Some of the research that I've done looks like people are thinking they're interchangeable, and that I pairs and this count thing will always work. This count the pound sign to get the count of a table is not getting you the count of everything that could be in a table. It's only getting you the array part of it. But like I said, in the game, I haven't really seen, I don't know that I've seen any instances of a table where it's anything other than a simple array. All right, so is that all we needed to go over for the basics of what a table is? Are you confused enough yet? Yes, yeah, there's still some other stuff to go over on the tables. So right now, I've just been adding to the table by creating a table. We haven't actually added anything to the table. So down here, let's see, let's get rid of this print since it doesn't always work. So the name of the table is T. If I want to add another item to it, you can use the bracket syntax. Let's see if 23 is equal to G. Let's see if that'll work. Yep. So we basically just pushed another value into the table. And to do this, you sort of had to know what the increment was. If we did another 23, I'm not 100% sure what would happen. We'll call it 555. Yeah, and so it just overwrote what the value of the 23rd, what the key of number 23 was. So there's other ways to do this in the Lua language. There's table insert. And for this to work, it's just doing the array part from what I can tell. You pass it in the name of the table, and then you pass it in value. What are we up to? FG. We'll try, well, we already used G once. Let's use H and see what happens. That's interesting. So see here, it put the H in before the F. And if we print, let's print the whole table. You're going to see that it's got the index of 6, I think. Yep, 6. I wonder if you keep doing that, what happens when it gets to 22? I guess it'll overwrite it. But it's important to understand that Lua can handle the fact, there's a name for it, it's a sparse table, I believe, that the indexes are not all sequential, and that's okay with it. It's also okay that if it has a mix, and of course it doesn't like that. Type. Yeah, I'm just going to call that type equals T. This highlighting part here kind of means there's something wrong, Expected something near T. Type. Because I forgot the closing quote on that as it's a string. That's interesting. And now it pushed it off to this end. Type equals T is at the end. All right. Those are all valid parts to be in the table, and I guess it doesn't really matter since it's not. I think I've also read that the items within the table are not always sorted. Not 100% sure on that. All right, so what else can we do? What if we just want to print a particular item in the table? What did I do that? I did type as the last one. What if you just want to print what something is and you know what the index is? So even though this isn't a number, type is still the index of that item in the table, I believe. And you use the syntax with the square brackets, and it came back as nil. Type should be equal to T. Let's get rid of this table insert. Nil. Maybe because I have to have it in quotes. Yep. So since type right here is a string, I needed to have that in quotes. If you wanted to get the second one, which I believe will be B, you can type in 2. Yep. And remember, it's printing all this other stuff because we still have this pairs loop here. Yep. Okay, so now that we have a mix of stuff in the table, let's see what the pairs and iPairs does. The name of the table, T, do, print, we'll print V, because that's the value of the key. I guess that's what K and V stand for, key and value. I like it. I think I just figured that out. And let's get rid of this print statement down at the bottom and see if this works. A, B, C, D, and E. Yep. We probably should print the table also. So we're getting the array when we do iPairs, but we're not getting 22 because it's not sequential to 5, right? This is 1, 2, 3, 4, 5. If we change this to pairs, we should get everything. A, B, C, D, E, F, and T, because type is equal to T. Okay, we'll spell that out so it's a little bit more obvious. Yep. All right, so let's see. We already went over how you could add something to the array by doing type square brackets and then a number for what the index or the key is going to be. I don't think we have an 11 yet. Let's see if this works. Yep, that worked. So there's another way that if your table is a dictionary style table instead of just an array, and you're using strings as the key, you can do the dot syntax. So I can do T dot wicker equals cool. And then when we run this, we've added that as something into the table. You can only do this type of dot syntax if it's a string. You can't do this with the number 12 or you'll get an error. If you want to do it with a number where you're specifying an exact index, then you need to use the square brackets. But if you're just incrementing a string, then you can do the, I was wondering where the prior thing went. And it's because I'm starting over every time. So it's just got game equals cool. All right, so I think that's enough of what the tables actually are. It can be a little bit confusing, but if you run through it a little bit, and the documentation is actually really good on the Lua Lua.org. A lot of this is really good. There's sort of a, you can just sort of page through here. There's all kinds of great information, and a lot of it's in pretty small bites that you can get some stuff. And then there's all kinds of additional information out on the internet. So in the game, let's see what something is that you would actually do with this. I'm going to declare we're going to add in one of the other videos we made something to randomly move units to different locations. So I've got some subs here. I renamed them all already just so it would be easier to work with. So I'm going to add, there's 4 subs. I'm going to add them into a table. And they should be sequential from there. I think the last one was 80. I think that's up here. Yep, 680, 679, 678. We can print, see what we get. And it didn't work. It's always good to check your work. I need to have them in their strings, so I need to have them in quotes. This is why you always check your work with print statements. Yep. And now what we want to do is iterate over those units and then run the code to randomly move them. So I need to go get the place unit randomly function. Let's see. And the function always has to load first, although we can put it underneath here. We just need to call the function down at the bottom. And let's see, I need to remember, I'm going to type some of this up here so that I remember how to do this. The last one, the random alt, is optional. I think actually all of these are optional. Those last 3 are optional. Distance, we'll do 150. Let's see, the side, I need to put that in there. This is going to be blue, I think. Pretty sure that's what I set up. And we'll go ahead and keep ship, because what we're going to do is loop over the table. So that was... So one of the ways you can do that is you could use count, because this is a straight up array type of table. So you could do a for I equals count of the table, do that, but I think we'll just use the I pairs thing. So this is going to be for k comma v in pairs units do. I'm going to put an end, and then we're going to call this function. Let's see, we're going to create a local variable called ship and set it equal to the value. We probably need to print let's print ship and see what happens without calling the function. Comment that out. This probably needs to be below this. And see what happens. I don't have the function call down below. Nope. Function shouldn't do anything. I'm going to turn this echo off. All right. So you can see that here is our table full of units. In this code here, we circled through every unit in this table, and we set ship equal to V, and V is the value in the key value pair. The key of this first one is 1, the key of the second one is 2, the value is this. So we were able to get that. We should probably be checking to see if this is not equal to, if it's equal to nil, local ship equals V. If V is not equal to nil, then end. We'll move this up. And now we'll call the function place unit randomly. The side is blue. The name is the ship up to 150 miles. Dun, dun, dun. That looks right. This and of course I got the cap locks key on. And now we're going to copy this part and put it at the bottom. We don't need to worry about this part being at the bottom, but the function needs to load before we actually call the function. And here we're calling the function with the side blue, the name of the ship, and the amount of miles away you want it to be. Let's go see if this is going to work. There's our 4 ships. Fingers crossed. And look at that, they moved. Oh my God, on the first try, this is the first time this has ever happened. And they're moving kind of a long ways away. We probably should have the miles a lot closer if we wanted them to actually be in the area where they started from. Let's actually move them back. I'm just highlighting each one and pressing the move key, the M key. Let's go back here. And let's change that to 20. That's interesting. They're all moving in the same way, and that's probably because of this math random seed. That is the bane of my existence. Now they're moving randomly. Good God Almighty. Still have trouble understanding what the random purpose of the random seed is in the Lua console and in the game. I can't. It used to be required, and now I just can't tell whether it is. Certainly, when you're calling math.randomSeed right now, they are all getting the same value. That is not a random value for each one. I think partly because it's going so fast that it's picking the same. It has something to do with the what second you're on or something. Boy, that guy almost looks like he's over land. No, he's still hanging in there in the ocean. All right, so then there's one more example I was going to show you with this, and that is that I set up some missions. So under the mission editor, I've got 3 missions. I'm going to put each one of these into a table that'll be like an array. We're going to call this local missions equals, and again, a table is always in brackets. This time I'm going to remember the quotes. I'll pre-do this so I can just paste stuff in. We got naval strike. And always check your work. Let's see if that works. Missions, yep. And now if we want to randomly assign those 4 units to one of those missions, let's see if we can figure out how to do that. So we're going to do the same loop down here. We'll move them and randomly assign them to a mission. So we're already doing the nil check, although actually one of the things we're going to do with that is to see if it actually works. We're going to delete this guy. And what's going to happen in the console? It's going to crash. Yep. That's because we don't have tool whatever. We need to emulate the console. And that is right down here at the top of the page. The game behavior is slightly different than what the console behavior is. In the game, it has better error handling. Whoops. Back to here. So now nothing's going to happen up here in the console, and it's not going to error. What we want to see is that the 3 ships still move. The 3 subs are still moving. So the nil check is working. If I take the nil check out, I think it will crash. And let's make sure of that. Local ship equals V if V is equal to nil. Print ship. It's still working. I wonder if we deleted the... No? Interesting. I think that's... I see why that's... I sort of understand why that's working, because we didn't set... The time that I have trouble with the nil check, if you don't do it, is when you set the unit equal to a variable. We're not doing that. It's still a good form that you do that. And now we need to figure out how do you change, how do you assign a unit to a mission? Send it to add mission, assign unit to mission, send edit assign unit to mission. And this is going to be ship. Let's see, that's, yeah, I believe that is the unit. And then this is the mission. We're going to set that up as mission. So right now, all we have is, and I'm going to comment out that because I do want it to show me an error if I have an error. So we have missions are equal to these 3 things, but I don't want to call them in order. I wanted this to be a random mission. So here I'm going to set, see if this will work. I'm just making this up. We're going to call this a local variable. Mission equals math.random 1, comma, and I'm going to use the pound count missions. That should be 3 because we have 3 missions. And then I need to get the index of whatever number it chooses, and that should be brackets. That should be missions and then brackets. You know, I'm going to call that M to make it shorter. Local M is going to be the index of the mission we want to choose. I wonder if that's going to work. Let's just try it. Attempted to get length of a global mission and nil value on string line 90M equal, that should be having an S on it. Can't find unit PL679. That's the one we deleted. But that might not matter. These are on missions. That one didn't get assigned one. That one did. 680 because it didn't like, it did exit the code. Believe if we get rid of this. So you can see that one's on Sea Control South. This one's on the same one. This one is on Naval Strike. Let's see if that changes. That one's on North now. That one's on North. That one's on naval strike still. A little suspicious. Now they're all on a naval strike. That one's on sea control south. Seems random. I think we did it. So I think that's about it. The tables can be pretty complicated. I certainly didn't go over everything that I could have. You can delete the table by just setting it to the empty curly brackets or just equal to nothing. There's also ways to remove something from the table, but that can be complicated because I guess if you know the index, that can get complicated. I'm not 100% sure what happens if you have 10 units in a table and you subtract the fifth one. I don't know whether that creates a hole for the fifth one or does it renumber the numbers 6 through 10 after that. I haven't played around with that yet. That is something to think about though if you try to do something like that.